In this video, we're going to talk about practice problems for MTE4, first degree equations and inequalities in one variable. So problem number one asks us to solve the equation x minus 2 is equal to 9. We're going to do that by adding 2 to both sides of the equation, and x is equal to 11. Problem number 2 asks us to solve 5x is equal to 40. Divide both sides by 5. X is equal to 8. Problem number 3, 5x plus 7 is equal to 42. It asks us to solve for x. This is a two-step equation instead of just a one-step equation like the ones above. First thing that we need to do is isolate the x's. So we're going to do that by subtracting 7 from both sides. When we do that, 5x is going to be equal to 35. Now we're going to divide both sides by 5, and x is going to be equal to 7. Problem number 4 asks us to solve the equation where x divided by 2 and 2600ths plus 8 and 3100ths is equal to negative 8 and 4300ths. So we're going to subtract 8 and 3100ths from both sides. That's going to leave us with x divided by 2 and 2600ths is equal to a negative 16 and 7400ths. X is going to be equal to, positive times a negative is a negative. We have 16 and 7400ths times 2 and 2600ths. 24. 42 plus 4 is 44. 36 plus 4 is 40. 6 plus 4 is 10. Slide over 1. 4 times 2 is 8. 2 times 7 is 14. 2 times 6 is 12, plus 1 is 13. 2 plus 1 is 3. Slide over again. This is going to be 8, 14, 13, 3. That's the same numbers again, just split over one place. 4 plus 0 is 4. 4 plus 8 is 12. 12 plus 1 is 13. 7 plus 1 is 8. 6 plus 1 is 7. 3. And I've got 4 decimal places. So this is going to be a negative 37.8324. That would be 37 and 8,324 10,000ths. Negative 37 and 8,324 10,000ths. That's how you would read that with place values. Number 5 asks us to, let's check that one with our calculator just to be sure. So we're going to have negative 8 and 4300ths minus 8 and 3100ths. And then we need to multiply that times 2 2600ths, get negative 37 and 8,324 10,000ths. Okay, we're in good shape. Solve negative 3, so y plus 6 is equal to 9. We're going to distribute negative 3y minus 18 because a negative times a positive is a negative. Now we're going to add 18 to both sides. That's going to give us negative 3y is equal to 27. Divide by negative 3. Now a positive divided by a negative is a negative. 27 divided by 3 is 9. Six asks us to solve for t. 5 plus 7t is equal to 23 plus t. Notice this time we have t's on both sides of the equation. So we're going to isolate those t's on one side by themselves. I'm going to subtract t from the right and from the left to give us 5 plus 6t is equal to 23. That got all my t's to the left-hand side. Now I'm going to subtract 5 from both sides of my equation to leave the t's by themselves on the left-hand side and get all the numbers on the right-hand side. Now I'm going to isolate my variable by dividing by the coefficient. 18 divided by 6 is going to be 3. Number 7 asked me to solve the equation 3 times the quantity x plus 2 is equal to negative 9 times the quantity x minus 7. So we're going to have to distribute and simplify both sides of the equation first. 3x plus 6 is equal to negative 9x plus 63. I'm going to add 9x to both sides because I want to put my x's on the left-hand side. 12x plus 6 is equal to a positive 63. Subtract 6 from both sides. 12x is equal to 57, right? Yes. And then x is going to be equal to 57 divided by 12. Both of those numbers are divisible by 3. So this is going to be 19 over 4, or 4.75, or 4 3/4. Take your pick. Okay. All of those are appropriate answers. Number 8 is negative 7 times the quantity y plus 4 is equal to negative 5y minus 2y minus 3. Again, simplify both sides separately. We've got a problem though, that when we try and get our y's together on one side, all the y's go away and I end up with a false equation that says negative 28 is equal to negative 3. This is false. This is called a contradiction. And it means that there's no solution to this problem. No matter what I put in for y, it's always going to be false. It's not going to come out to be true ever. No solution is the same thing as the empty set right there. That's where it says the empty set for all real numbers. All real numbers would be if it's always true, it would have a finite solution set, like the problems that we've done before. If it's a conditional equation, it's only true in certain cases. All right. Number 9 asks us to solve the equation S is equal to A minus D for A. So this is just an example of I don't have to put numbers in to solve. I can solve for a letter. To get A by itself, I need to get rid of the subtraction of D. So I'm going to add D to both sides. S plus D is equal to A. So I can say A is equal to S plus D. We have the distance, rate, time formula here. D is equal to RT, but they want us to solve for T. So we're going to get rid of the multiplication by R. Let's say that D divided by R is equal to T, or we can say T is equal to D divided by R. Next, we have our perimeter formula for a rectangle. P is equal to 2L plus 2W. They want us to solve for W. So we're going to have to get the L's away from the W's. Then we're going to need to divide everything by 2. P divided by 2 minus L is equal to W. It would be also correct to say P minus 2L all divided by 2 is equal to W. That's just a little more complicated. Let's make sure that you know that this is an L and not a 1. I'm going to write it in cursive so that you know that that's an L. Okay, there we go. Let's clear everything so far. On to number 12. 12 asks us to solve the absolute value equation 15 minus 5t is equal to 55. First thing I can do if I want to is I can factor 5 out. Comes out in absolute value bars, and the absolute value of 5 is 5. So I can divide both sides by 5. That's some smaller numbers for me to deal with. That makes my life easier. So now this means that 3 minus t has to be equal to negative 11, or 3 minus t has to be equal to 11, because the only two numbers that have an absolute value of 11 are going to be positive 11 and negative 11. When I subtract 3 from both sides, this equation is negative t is equal to negative 14. Divide by negative 1, t is equal to 14, or when I subtract 3 from both sides, negative t is equal to 8. T is going to be negative 8. So my answers are t equals negative 8 or 14. Let's not use the set notation yet. Let's just write it this way. There we go. We could write it in set notation without the t there and say that those would be my t values that would satisfy the equation and make it true. Okay. Now we're ready for some inequalities. 2 and 5/10 x plus 5 is less than or equal to, that line underneath it means or equal to, 16 and 4/10. State the solution using inequality notation. So we're going to subtract 5 from both sides. When we do that, 2 and 5/10 x is less than or equal to 11 and 4/10. I don't like the decimals, so I'm going to multiply both sides by a positive 10. And that gives me that I'm going to divide both sides by positive 25. So x is less than or equal to 1/14 over 25. 25 is only divisible by 1, 5, and 25. None of those numbers go in there exactly. So I am done. That's my exact answer. If I want that answer expressed as a decimal, let's take 1/14 divided by 25, and I'll get 4 56/100. The reason I went back to a decimal for my final answer is because I started off with decimals in my original problem. So it's probably how they wanted the answer stated. That was number 13. Number 14 asks for me to solve the inequality 5 times the quantity x plus 2. It's greater than or equal to 3 times the quantity x plus 9. 5x plus 10. It's greater than or equal to 3x plus 27. I'm going to bring the x's over to the left by subtracting 3x from both sides. When I do that, 2x plus 10 is greater than or equal to 27. Subtract 10 from both sides. 2x is greater than or equal to 17. X is greater than or equal to 17 halves, which is the same thing as x is greater than or equal to 8 and 5/10. Number 15 asks me to solve the inequality -3/8. T is less than or equal to 5. So we're going to multiply both sides of the equation by the reciprocal of -3/8. So we're going to multiply by -8/3 and -8/3. When we multiply by a negative, we're going to have to change the direction of the inequality sign. It's -40/3. So T is greater than or equal to -40/3. I'm just going to leave it like that. That is not going to come out with a nice decimal. It's going to be a repeating decimal. So this one says, yes, solve it with interval notation. We did that. Oh, interval notation. So -40/3 to infinity. There we go. So that's my interval notation for that problem. Number 16 wants me to write the solution in interval notation for the given solution set on the number line. So they've actually already basically drawn it out for me, that if there had been a solid dot there, that would be the same thing as this closed bracket. And if there had been an open circle here, that would be the same thing as this parenthesis. But they want us to have interval notation -4 to 5 like that. 17 wants us to solve the inequality. X plus 3 is less than or equal to -2. I'm going to subtract from both sides. Doesn't tell us to write the answer in interval notation, but since we've been doing everything else in interval notation right before this, let's practice it. X is less than or equal to -5. So we're going to have an answer of -infinity to -5. 18 says a company pays its sales representative 35 cents a mile if they use their personal cars. Sales representative submitted a bill to be reimbursed for $148.05 for driving. $148.05. How many miles did they drive? So we're going to divide both sides by 35 cents. X is going to be equal to 148.05 divided by 35 hundredths. So X is going to be 423 miles. Number 19 asks us if an object traveled 230 miles at a rate of 25 miles per hour. How long did it take to travel this distance? We already know the formula from earlier. So we want time is equal to distance divided by rate. So our time is going to be the distance of 230 miles divided by speed of 25 miles per hour. Our T is going to be measured in hours. 230 divided by 25. It's going to be 9 2/10 hour. We If we want to convert that to hours and minutes, that's 9 hours and 12 minutes. Because each 1/10 of an hour is 6 minutes, so 2 times 6 is 12. That was number 19, so we're on number 20. Hardware store is running a 20% off sale. And the item has a list price of $14.40. What is the item sale price? So 20% off of the regular price is going to be 80% of the regular price. So 80% of $14.40 is what? Is an equivalent question. So 1440, 80%. Going to be $11.52. Number 21 says tickets for a college basketball game are $9 for the lower level seats and $5 for the upper level seats. For a particular game, 850 lower level seats that were sold at $9 each were sold. We have the unknown amount of upper level tickets were sold at $5 a piece, and we have $96.50 was in the cash box tonight. So this is going to be 5x plus 72 plus 4 is 76. I'm going to subtract 76.50 from both sides. We get the 5x is equal to 2,000. Divide both sides by 5. And we get the x is going to be equal to 400. There were 400 upper level seats sold. All right. Last problem, number 22 for this section, asks us the bill for repairing a car is $345. The cost of the parts, the fixed cost of $160, plus the cost of labor was $37 per hour. How many hours did the repair take? So we're going to subtract 160 and get 37x is equal to 185. Divide both sides by 37. And we get that it was exactly equal to 5 hours. That's the end of our MTE 4 problems. We'll come back and talk about MTE 5 next time, which is linear equations, linear inequalities, and systems of equations in 2 variables.